So if you haven't figured it out by now, this section of math that we're doing right now, statistics, is more of a discussion than it is just simply a number crunching. And yeah, you get the opportunity to crunch some numbers when you're calculating the standard deviation, as we did yesterday or the day before with the block schedule with this. But more than anything, it's important that we understand how to talk about it. Okay, so most of us can do some calculations, and I think our calculations yesterday found that 7.6 was the mean, and our standard deviation was 1.3. Now, as we're building our image here, and I want to take some time to do that, these lines here should be at a distance out that measures, that basically gets to where this is concave up and turns to concave down. It looks like it's a straight line there, but to some degree this thing is curved upward where it's going to get wet in the rain, versus concave down where the interior, the inner side of the curve is going to stay dry from the rain. Okay, it's facing up here, it's facing down here, so it's that point, and it's hard, it's impossible to detect here, but that's what you're shooting for. You're shooting for finding that point of inflection where it changes from concave up to concave down. So that's how you're going to draw it, and then the distance between these two here should be the same as you go to the left. And remember, this distance on the end here should only be about 2.5% of the overall data, okay? Because 95% is going to fall in between, 68% falls within the next. So the standard deviation was 1.3, which makes this 8.9 and makes that 10.2. And as you go down the other way, you've got you got 6.3 and then 5.0. Okay. I never ask my students, whether my AP Stat students or my Algebra 2 students, to even draw the third one. You know it's there, and if I ever ask you where 11.5 is, I'm sure you could draw a line that's about the same distance beyond, but you're never going to be able to get an accurate read of beyond that is only 0.15% of the overall data, okay, which is half of 99.7. Anyway, if you can get me this, I'm going to be happy, and so are the rest of us in the Algebra 2 department. Anyway, in terms of the standard deviation, how would you say a baby weighing 8.9 pounds compares to the mean? Well, 8.9, you know, that triggers maybe 68% that falls within one standard deviation. But what it's asking for is how many standard deviations, how many measurements above average is it? Well, it's one standard deviation above average. Okay. When you talk about something like this, how would you say a baby weighing 9 pounds compares to the mean? The problem there is, up until now, we've only been talking about nice numbers. Well, 9 isn't so bad because it's close to 8.9, but it's not. We can't say we can no longer talk about it in terms of 68% or 95% or even 13.5% or 64%. Any of the ones that we looked at yesterday. We just need to say that it's more than. And you might even want to say, if you want to get specific, a little more than, right? One standard deviation above average. Okay, which is accurate, but it's, again, if I wanted to say what's the percentage, well, we'll talk about that in just a second. Let me just say this. If I wanted to be more specific about how many standard deviations above average, I know it's going to be a decimal. I'm going to give you an equation here. There's an equation for a z-score, and the equation for that z-score is x minus x bar divided by sigma. Okay. In terms of what we're doing here, that right there represents the standard deviation. That's what we've been calculating in the past couple days. That right there represents the mean, which we also know and understand. This right here, in the past, has referred to all of the x values. Okay, but in a case such as this, we're looking at a specific x value, or a specific term in the set that created the mean. Okay, and what is it then? With the standard deviation, we've got to get to know what the standard deviation in terms of context. Standard deviation is the average distance from the mean. Well, what is a z-score? That one's just as simple to explain. It is the number of standard deviations from the mean. Now, you might want to make sure that you understand from could be above or below. So the sign matters. If it's a negative number, that means it's below average. If the z-score is a positive number, that means it's above average. And we'll look at that in the next problem here in just a second.